Good morning, everyone. Today we are going to discuss about forward reasoning and backward reasoning. First, we will see what is an inference engine. So, inference engine is the core reasoning component of an artificial intelligence system or expert system. For example, we can say that how the Google Maps decide the best route, and also the doctor decides the diagnosis. So we can say that an inference engine is basically the decision-making brain that reasons using facts and rules. We have already seen that. Then we will see the main components of the inference engine. Here we have knowledge base, working memory, inference mechanism, and control strategy. These all things we have already discussed. We can just compare with the human analogy. Knowledge base is similar to what the human knows through books or experience. Working memory means what the human think about right now, and inference mechanism means what is the human reasoning process, and control strategy means the human will decide what to think next. So we will see once again, knowledge base means there will be some if then rules. That means if we have fever and cough, then it may be flu. Then if flu, then it leads to rest is needed. So similar to that, it contains facts and rules and that represented using logical statements. That working memory means that store the current facts and also the updated dynamically during reasoning. That means we can consider fever equal to true, cough is equal to true. So then after reasoning, what will be the new conclusion that will also added to the working memory. Then inference mechanism means here we are applying rules to the facts. So what rule we will be applied, and it will generate new facts will be generated, and this inference engine actually matches the facts and applies the rules and derive new facts, and this fact will be added to the working memory. Then control strategy, what it will do is it will select which rule we have to apply next, and it resolves conflict when multiple rules are applicable. So here we can say that first we have facts, then we will match this facts with the rules, then fire the corresponding rule, then the new facts will be produced, and that we can add to the working memory, and the cycle repeats. So we can say that inference is not one step, it is a cycle. So it is connected to forward chaining and backward chaining. We will discuss in detail what is forward chaining and backward chaining in this session. So we can say that an inference chain is reasoning in steps, not a one-shot decision. So here, the inference engine, here we can see an example. So we have already seen an inference chain is a sequence of rule application where each fired rule produces new facts, and that triggers the subsequent rules. So that's showing the complete reasoning path from initial facts to the conclusion. So here, the inference chain means a rules firing from one to the another to reach to a conclusion. So each rule depends upon the facts produced by the previous rules. So here we can see x is equal to, here we can see the three rules, rule 1, rule 2 and rule 3. So rule 1 is if x is true, then a is true. And rule 2 is if a is true and b is true and c is true. So a, b, c are true, then y is true. And rule 3 is y is true, then y is true and d is true. So y and d is true, then z is true. So these are the three rules we have. And from the diagram, we can see that here x is true. So x is true. Then here it will check with each rule, and the rule 1 is matching. So apply rule 1. That is x is true means rule 1 fired. So rule 1 fired means here a is true. So rule 1 gives a new fact, that is a is equal to true. So this new fact goes to the working memory. Now we will check a is true. You can see B is true and C is true. Then we will check with the rule, and here rule 2 is matching. So rule 2 is fired, and then we will get a new fact, that is Y is true. So we added to the knowledge base. Then we have Y is true and D is true. Then we will check with our rules. So third rule is matching y is true and b is true, then z is true. So our new final conclusion, that is z is true. So here from this ordered sequence of rule firing is called an inference engine. So X leads to A, and then A combines with the B and C to produce Y, then Y and D to produce Z. So the diagram visually shows how the intermediate facts help to reach the final goal. So we can say that an inference chain is a sequence of rules applied by the inference engine, where each derived fact triggers the next rule until the final conclusion is reached. So here we will see forward reasoning in detail. So in the case of forward reasoning, non-facts are already in the working memory. Rules are if-then conditions, and we are applying rules using modus ponens, and the new facts are generated. And this process repeats until no new facts or goal is reached. So here, if we have a rule P, if P, then Q. So if P is true means therefore Q is true. So forward chaining is nothing but repeated modus ponens. So here you can see that it works in forward direction. So that means it will start from the basic facts. So if we have facts like X is true and B is true and C is true, so we will check with our rules if there is any match in the rule. So if we have a rule, if X is true means A is true. And if we have another rule, if A and B and C is true, then Y is true. So then what we will do is, first fact, that is X is equal to true, is matching with the one rule. So then the corresponding rule will be fired and a new fact will form. So that new fact is also added to the working memory. And now we have that is according to our rule, if X is true, A is true. So now we have A is true, B is true and C is true. So according to that second rule, Y is true. So our final conclusion is Y is true. So each conclusion become a new fact and made to the another rule. So here we are starting from facts, rules, then new facts, then final conclusion. So here we can simply say that we are starting from facts and it until we reach the conclusion. So the cycle will repeat until we reach the final conclusion. And here each new conclusion become a new fact, and these new facts may trigger more rules. So here where we will store these new facts, we were storing in the working memory. So initial facts are loaded, and when the new rule fires, then new facts will be added, and this memory keeps growing during reasoning. So forward chaining is data driven and backward chaining is goal driven. So all these properties explain why this forward chaining is called a data driven reasoning. We can discuss the properties of forward chaining. So we have already seen that the forward chaining starts from the basic facts at the bottom and build up towards the conclusion. So it is starting from the facts and it will find the intermediate facts and then grows to final conclusion. So bottom up means facts first, then goal later. So that is the first property. Then second property is fact-based reasoning. So forward chaining never actually guesses. So it only reasons using the facts that are already known. So it uses non-facts or data, and also it starts from the initial state and move towards the goal state. So if the facts is not available in the working memory, then the rule will not fire. So the third point is data driven method. So here in forward chaining, data controls the reasoning. So that means there are available facts are there. So that decide which rules are checked and which rules are fired. So if there is no data means there is no rule firing. And the next point is incremental knowledge growth. So incremental knowledge growth. So when a rule fires, a new facts are created. So that facts are added to the working memory. So we discussed all these points, and these new facts may trigger the more rules. So knowledge grows gradually, not all at once. So we can say that we are starting from facts and it will derive more facts and even more facts. So next point is goal emerges naturally. So that means uh, we know that what is the goal. So forward chaining does not need a predefined goal. So system keeps firing rules, and the final conclusion that appears actually naturally. So goal is the result, and we are starting from the initial state, and whenever we reach the goal state, we will stop it. So we can say that the goal is reached as a result of rule execution. So forward chaining discovers the goal, it doesn't chase it. So these are the properties of the forward chaining, that is bottom-up approach, fact-based reasoning, data-driven method, incremental knowledge growth, and the goal emerges naturally. So the forward chaining starts with the facts, and backward chaining starts with the goal. So that is the difference between forward chaining and backward chaining. So here the fact decide rules, and rules create facts, and the goal appears at the end. So we will see an example. So here you can see a set of rules are given. Here rule 1, if student is excellent in academics and he is good in sports, then he is an all-rounder. So here the goal state is he is an all-rounder. And here the next rule is if student get marks above 80 and he is good general knowledge, then he is excellent in academics. Then the third rule is if student is making centuries, then he is good in sports. So these are the rules are given, and here the goal state is he is an all-rounder. Then given facts in the working memory, we can see student get marks greater than 80, student is making centuries, and student is good in general knowledge. So these three are the facts in the working memory, and we have these three rules. It is also available in the working memory. So in the forward chaining, we will start with the facts and rules. So here we can see we will start with the initial state. Initially, we have three facts in our working memory. So we are starting with this. So usually we are starting from the first fact, that is student gets marks greater than 80. So we will check whether it matches with any of the rule. So when here you can see that it matches with the first point, that is matches with the if student gets marks 80. So here you can see, but there is a one more condition. There is a and is there. So if this is also true, then only we can fire this rule. So we will check in the facts whether it contains he is good in general knowledge. Yeah, he is good in general knowledge also. So we can say that this is satisfied. The rule 2 condition is satisfied. So we can fire this. So we can fire that he is a excellent in academics. So this means this is the intermediate fact. So this we can add to the working memory. So our new fact is student is excellent in academics. That also we added to the working memory. So that means now we have four facts in our working memory. Then again we will check the rules. Here you can see next fact is student is making centuries. So we will check whether it matches with any of the rule. Yeah, here you can see he is making centuries. This is matching with this rule 3. Here you can see if student is making centuries, then he is good in sports. So we can fire the third rule, and we are getting a new conclusion that he is good in sports. So this is our new fact. He is good in sports. We can add this to our working memory. So now we have there are five facts in our memory. That is, student gets a marks above 80. Student is making centuries. Student is good in general knowledge, and a student is excellent in academics, and a student is good in sports. So all this we are adding to the working memory. So here we have five facts in our working memory. That means intermediate facts also we added to the working memory. Then we will check. Then we will check it next. Next, facts, that is matching with any of the rules. So here we have a student is excellent in academics and the student is good in sports. These here we have, you can see here, this is the first fact, second fact, and this is the third fact, and this is the fourth one, and this is the fifth one. Now we have um, five facts in our working memory. So now we will check. Student is excellent in academics, whether it matches with any of the rule. Yeah, it is matching here. You can see student is excellent in academics. Then student is good in sports. Is it matches with any of the rule? Here you can see here also it is matching. So that means these two conditions are satisfied in the working memory. So we can fire this rule, and the final conclusion is he is a all rounder. So that is our final conclusion. We reach the goal state. So we can conclude that student is all rounder. So this is the best example of forward chaining or forward reason. Next we can see backward chaining. So now we will see, we have already seen the forward chaining. Now we can move to backward chaining. So forward chaining asks, what can I conclude from these facts? And the backward chaining asks, is this goal true? So we will see how we can do that. So backward chaining is a goal-driven reasoning technique in which the inference engine start with a goal state and works backward to verify whether the required facts are true. So we will see reasoning actually begin with a non-goal state. So it will start with the desired goal state, and system tries to prove the goal. So yeah, so for example, we can say that like a doctor starting with a suspected disease and checking the symptoms. So this is an example of a backward chaining. So here we can say that it is starting with the goal, it will generate sub goals and then to the facts. So backward chaining moves from goal to fact. So this is why it is called the top down approach. So this is opposite of forward chaining. So here we can say that it is a top down approach. Then next point is uses modus ponens and reverse. That means here if A, then that is a rule. The rule will be like in this form: if A, then B. So in backward chaining, we are starting with the goal state. So if goal is B, so we are starting from the back. So that means if goal is B, the system asks, can I prove A? So to prove B, we have to try to prove A. So the forward chaining applies rules forward and backward chaining traces rule backwards. So then we can say that, for example, we will see if fever and cough. Then if we have a rule, fever and cough is there, and so this is the if condition, fever and cough, then flu. So this is our rule. So here our goal state is flu means, then that means our in the goal state we are taking flu. So we are taking it as flu equal to true. So to prove flu we have to check, is fever true, is cough true. So if facts are missing, then we can ask the user or try other rule. So if it is true, then we can say that these facts are there. So what we have taken is true. The goal state is true. So this comes directly to fact verification. So if required facts are not present, the system searches for other rules to prove them or ask the user for the information. So that means backward chaining only looks for facts that are needed to prove that goal. So if a fact is missing, then it will search other rules or ask the user for input. So this is why it's interactive in many expert systems. Then next property is selective rule evaluation. So that means only rules related to the goals are checked. The irrelevant rules we are not taking. So we ignore the irrelevant rules. So that is why backward chaining avoids unnecessary computations. Then this is efficient for diagnostic system. So that means it is best suited when
goal is specific. For example, medical diagnosis, fault detection, troubleshooting system. That means when the goal is clear and options are limited, then backward chaining is faster. So we can say that forward chaining is data driven and it is a uh, top down. Sorry, forward chaining is data driven and the bottom up, while the backward chaining is goal driven and top down approach. So the backward chaining start with the answer and check whether it is true. So forward chaining start with the facts and move towards a goal, and backward reasoning start with the goal and move towards the facts. So here we have an example. Here you can see here our goal state is B, that is he is fit. So then we can say that there is a rule is there. A implies B. That means if he is exercising, he is fit. And then what we will do is we are backward chaining. We are starting with the goal. So we will check that he is it is there. So it is given in the goal state. He is fit. So we will check whether any rule is matching with the he is fit. Here you can see that here this rule he is fit is there, but there is a condition if he is exercising. So we will check in the working memory, is there any fact is available that he is exercising. So the required fact is he exercises regularly. So if that particular fact is available in the working memory, then that means A is true and B is true. So we will see an example. Here you can see that um, the same example we already discussed with the forward chaining, but now we will discuss with the backward chaining how we can solve it. So here we have three rules. First one is if student is excellent in academics and he is good in sports, then he is an all-rounder. That is our goal state. He is an all-rounder. Then the second rule, if student get marks above 80 and he is good in general knowledge, then he is excellent in academics. And the third rule, if student is making centuries, then he is good in sports. Then we can see there are three facts in our working memory. So here we have student get marks above 80, student is making centuries and student is good in general knowledge. So there are three facts. So in the backward chaining, we will always start with the goal state. So we are starting with the goal state. So student is an all-rounder. We are starting from there. So we will check whether it matches with any of the rules, the part after then. So it matches the then part. So we will see here rule 1. In rule 1 it is matching. So this is matching in rule 1. So but there is a condition. You can see these two conditions are available in the working memory. Then we can say that he is an all-rounder. So we will check whether these two conditions are available in the working memory. First one is student is excellent in academics. That is not available. Then he is a good in sports. That is also not available. So what we will do? So we can add these two as sub goals. So these becomes the sub goals. Then again we will check whether these sub goals are available in any other rules in the then part. So we will check the first one. Student is excellent in academics. Is this available in any then part? So here you can see this is available here. So we will check there is two conditions. If student get marks above 80 and he is good in general knowledge. So these facts are available in the working memory. So what we will do? So here you can see that these two facts are true. Then we can conclude that this is true. So this sub rule is true. So this sub rule student is excellent in academics is true. So then we will see next one, that is then we will see student is good in sports. So we will check whether it matches with any of the if part, then part in the rule. So here you can see student is good in sports, that is matches with the third rule. So then we will check whether this is corresponding facts is available in the given facts. Yes, here you can see this matches with the second one. So it is matches with the second one. So that means, so that is true. So that it is true means we can say that this subgoal is true. So now we proved that these two subgoals are true. So these two subgoals are true means, we can see these two subgoals are true. True means then whatever will be our goal, so that is true. That is, the student is an all-rounder is true. So this is the explanation of the backward chaining. So we already discussed in the previous slide. Now we can conclude that our goal is proved. So we can compare forward chaining and backward chaining in artificial intelligence. So the first point. So forward chaining start with the available data, and backward chaining start with the desired goal. So one start with what we know and other starts with the what we want to prove. That is the first point. Then the second point is the type of reasoning. That is, forward is data driven and the backward is goal driven. So data pushes forward and goal pulls backwards. Then the third point is direction. That is, forward reasoning is bottom up approach and the backward reasoning is top down approach. Forward means it is from facts to conclusion and backward is from goals to fact. Then the fourth point, search strategy. So forward we are using a breadth first search. Then in the case of backward it is depth first search. So forward explores many rules and backward focuses on a narrow path. And the fifth point is speed. Forward is slower and backward is more faster. So forward checks many rules and backward checks only goal related rules. So it is more faster compared to forward check. Then the sixth point is regarding application. So forward chaining that is used for planning, monitoring, control systems and interpretation systems. And in the case of backward chaining, that is actually used in inference engine, theorem proving, proof assistance and diagnosis systems. So we can say that if you know the call, then use backward chaining. If you don't, then use forward chaining. So forward chaining is from facts, rule, then goal. And backward chaining is goal, rule, and facts. So the forward explores more and the backward focuses more. Thank you.